Hi, today we're going to be learning about the basic math behind kaleidoscopes. Kaleidoscopes are made with two or more mirrors or reflective surfaces positioned at an angle to each other, forming a V-shaped or a triangle. A collection of objects are positioned at one end of the mirrors, and there is an eye hole at the other. The objects that fall into the position within the V or triangle are then reflected toward the eye hole. The angle between the mirrors will determine the number of reflections that can be seen. Let's start simple and think about it. How many images are seen when there is one object in front of a plane mirror at 180 degrees? One image. It's like looking into your standard mirror. The same could be said if you had two mirrors that were 180 degrees from each other. Now, how will the number change when the angle between the mirrors is changed? Pause and think about it. As the angles get smaller, the number will grow. The smaller the angle allows for multiple reflections to be created. Pause the video and go to the applet. Change the angles between the mirrors to the angles that are seen in the table, and count the number of images seen and record them in the table given. These should be the values you've obtained. 120 degrees should be 2 images, 90 degrees should be 3 images, 72 degrees should be 4 images, 60 degrees should be 5 images, 45 degrees should be 7 images, 30 degrees should be 11 images. Now pause the video and use your table to complete these predictions. Predict the angle between the mirrors when you see 9 reflections and 6 reflections. Then predict the reflections you will see when the mirrors are at the angles 20 degrees and 15 degrees. If you get stuck, go back to the applet for help. These should be the predicted values you got. For 9 reflections, about 36 degrees. For 6 reflections, 52 degrees. 20 degrees will give you 18 reflections, and 15 degrees will give you 24 reflections. Now pause the video and come up with a formula that relates the number of reflections seen to the angle between the mirrors. A little hint, think about how many degrees are in one circle. The formula you should have gotten should be the number of reflections equals 360 divided by the mirror angle minus 1. Now pause the video and use the formula to verify your predictions from question 3. Then find what mirror angle would give you 8 reflections. Using the formula, you should have found that a 40-degree angle gives you 8 reflections. More complicated kaleidoscopes are made with two or more than 2 mirrors. Adding more than 2 mirrors results in a little bit harder math. Having multiple mirrors in a kaleidoscope results in reflections of reflections. And this, combined with the orientation of the mirrors relative to each other, is what creates an image we see. A kaleidoscope is one of the oldest science toys and has been around for 200 years and is still very popular in today's world. Due to the randomness of the tumbling action, you will never see the same set of images twice. As a result, the kaleidoscope produces a constantly changing set of unique yet breathtaking images. Now you know the basic math behind how kaleidoscopes work.